This is one-step addition equations, video 1. So when we're solving one-step equations or any equations, what we want to do is isolate the variable. What that means is we want to get the variable by itself. So let's look at the example x plus 4 equals 6. I have a picture or a diagram of a balance beam. On this balance beam, on the left-hand side, I have an x. With it, I'm going to have 4 positives. On the other side, I have 6 positives. So how many positives must x represent in order for the two sides to be balanced? 2, right? Well, that's obvious here. However, as equations get harder, we need to have a systematic way to solve them in order to determine what the variable represents. So I'm going to show you the steps for doing this with an example that's easy to imagine. So what we're going to do is we're going to remove the 4 positives that are beside our x, and that'll get the x by itself. And whatever we're left with on the right-hand side of our balance beam or our equation over here is going to be the answer. Now, the way we get rid of the 4 positives is we add 4 negatives. We know that whenever we add positives and negatives together, that gives us what's called zero pairs, or they cancel each other out. Since I added 4 negatives to the left side, I have to do the same thing to the right side in order to keep the equation balanced. And that also keeps this equal as a true statement. The minute I do something different to each side of the equation, that equals is no longer a true statement, and it's important to keep it a true statement. So now I can cancel every 0 pair. So all 4 of these cancel, and then 4 on the other side cancel as well. And we can see indeed that when x is by itself on the left-hand side, we're left with 2 positives on the right side. So 2 is what x represents. So this is how equations work, but now let's see how to write our steps with symbols. So since I added negative 4 to 4 in order to get rid of that positive 4, that's how I'm going to show my steps. So I show the operation of addition, and I show what I'm adding, the negative 4. And that is going to give me the 0 I'm looking for. So 4 plus negative 4 is 0. I'm trying to get x plus 0 here, because that's how x gets by itself, as we're adding nothing to it. I bring my equals down. Now, since I added negative 4 to the left, I'm going to add negative 4 to the right as well. And 6 plus negative 4 is 2. X plus 0 is x. Bring our equals down, and we get x equals 2. So these are the steps that you would show. Now, we also need to know how to do a check step. So a check step is where you substitute your answer in the place of the variable that represents that number, and you see if you get a true statement. So I'm going to put a little check here to show my check step, and I'm going to put 2 in the place of x and see if I get a true statement. 2 plus 4 does equal 6, and 6 equals 6. Therefore, this is true, so I know that my answer is correct. Let's try another example. So I've written this problem, x minus 3 equals negative 7, for another example. Now, whenever you're working with subtraction, we're always going to change that to addition. So the first thing I'm going to do is change this to x plus negative 3 equals negative 7. That way, I can tell that that 3 is actually a negative. Now, in order to get rid of that negative 3, what should we add to it? A positive 3. Good. And if we do it to the left side, what do we have to also do? We have to add a positive 3 to the right side. This keeps our equation balanced, which means that that equals stays a true statement. So now when we simplify, we get the x. Bring down your plus. Negative 3 plus 3 equals 0. Bring down your equals. Negative 7 plus 3 equals negative 4. X plus 0 is x. Bring down your equals, and that's negative 4. Now, you really don't have to show me this step right here, although it's extremely important. This step, where we get x plus 0 equaling negative 4, you don't have to show. Most people actually skip it once they get good at solving equations. However, you can keep it in there for now as you're learning. It's actually very important because what we're showing here is we're working with addition. And whenever you're working with addition, you have to have plus 0 to get something by itself. Do you remember what property that is? That is the identity property of addition. Anything plus 0 equals itself. So if we have an equation where something is being added to x, we need to end up with x plus 0 in order to get x by itself. So that's actually very important, but you can skip showing that step if you'd like. The next thing we're going to do is a check step. So for my check step, I'm going to substitute -4 in my answer in the place of x. Always substitute it back into the original problem before you change the sign or anything in case you made a careless mistake. So we get -4 plus -3 equals -7, and that gives us a true statement. So therefore, this answer is correct. Now, oftentimes when you're working on a test or quiz, you'll do your check steps in your head. However, I will require you to show check steps as you are first learning. In order to solve equations, we are going to use inverse properties to get x by itself. So the inverse property is how you undo something. So the inverse of adding a positive is adding a negative. We used to think of it as the inverse of adding is subtracting. So when a number is being added to x, you're going to use the opposite property. So we're going to add the opposite to both sides. When a number is being multiplied by x, you're going to use the reciprocal property. So instead of dividing, we're actually going to multiply by a reciprocal, which you'll see when we get to multiplication equations. When x is being squared, then you'll take the square root because that's the inverse of squaring. When x is being square rooted, you're actually going to square it because those two are inverses. So whatever inverse operation you perform to the side with the x, you must also do the same to the other side. And that keeps the equation balanced or equal. So try these two problems, add them to your notes, and then use check steps to check them and come back to this video after you're done. Here are the steps and answers for these two problems along with the check steps. Take a minute and make sure that you are doing these correctly, including all of your steps. Now let's move on to the next page. So here's an example with decimals. We always want to change subtraction to addition if we see subtraction. What are we going to add to both sides? Positive 3.2, right? And show the addition symbol to show that the operation we're performing is addition. Then we're adding a positive 3.2. So we end up with x equals -4.4. I'm going to pause and do a check step. And you can see that my answer is correct because my check step works. Sometimes you will have more than one number that will need to be added together before you actually start solving. So it's important to simplify both sides of your equation before solving. And what that means by simplify is adding any like terms. So you can see here that 5 1/3 and 2 1/6, those are like terms because they're both constants and they need to be added together before we start solving for G. So the first thing I'm going to do is I'm going to change subtraction to addition to see that that 2 1/6 is actually a negative. Then I'm going to need to get common denominators because these are fractions and they're like terms. I'm going to get common denominators and add them together. So I have common denominators and now I'm going to add my two like terms. So when I add 5 2/6 plus -2 1/6, I'm actually subtracting since they're different signs. So I get 3 1/6 plus G equals -9. Or you could write G plus 3 1/6. It doesn't matter. So I'm going to add -3 1/6 to both sides to get the G by itself. And I end up with -12 1/6. You will see over to the right-hand side, I have showed my check step by substituting in my answer, -12 1/6 for G, getting common denominator with the 5 1/3 to 5 2/6, and then adding everything together. So here I added these two numbers first since they had same signs, and then when I added my different signs, I actually show the work here because you have to subtract and then keep the sign of the bigger. So this one is correct. So I have 3 problems that I'd like you to try. Make sure you do these in your notes and show your steps and your check steps. And then you will be done with this first video.